So again, thank you, Ignacio, for the introduction and for the acknowledgement. Just to give you a small presentation or a small introduction about AIDIGITS, it will take a couple of slides. We have been working in the field of BIM and digital transformation, especially for construction, since almost 24 years. As Ignacio said, I've been working in a mega construction company called CCC. It was ranked number 14 in one of the years in the last 7 years. I have established BIM in that organization since 1997. And a couple of years ago, I have established my own organization for BIM and digital construction. I'm the owner and I'm running AIDIGITS, plus 3-4 more companies for BIM and digital construction. I have a total of 200 engineers and almost 45 automation engineers. We have done more than 200 projects worth of $45 billion of value, and more than 20 million square meters of building space and infrastructures, and oil and gas. Part of our work was oil and gas. And as I said, we have diversification in the scope of what we do. We do civil infrastructure, buildings, and oil and gas projects. When I say infrastructure, I mean rail, roads, bridges, tunnels, highways, any kind of construction, no matter what is the size, what is the complexity. Our work spans during the full life cycle of facilities, from design through construction until handing over and beyond, going to facility management and operational maintenance. After the presentations that you have received from other presenters, the amazing knowledge and great similarities between civil projects and electromechanical projects when it comes to BIM and digital construction. So we have actually, when we started BIM in CCC 23 years ago, we were inspired by the mechanical advancement in utilizing 3D applications for managing the design and the procurement processes of mechanical projects. And that's why we have we have searched for a way where we can capitalize on 3D technologies and use it for civil construction. That's why since 1997, we've managed to find 3D solutions that were focused on buildings and later for infrastructure. And then we have managed to develop a great, let's say, portfolio of applications and workflows where BIM was utilized mainly for construction, because CC is mainly a contractor, and also, of course, to manage the design process and the handing over process and beyond. We have realized that now BIM become very advanced. There is a lot of workflows, advancement in this technology, and why not to use the same concept to advance the 3D implementation in the mechanical projects, in oil and gas projects, in industrial plants, to make sure that we can use similar workflows to implement BIM for controlling the construction process, the time, the quality of construction, the planning, and also the handing over process, the cost, managing the budget, and also managing the quality of the final product. In the next slides, I will show you some examples where we have implemented the same BIM workflows in real oil and gas projects. And then I will give you one quick round in one of the huge mega projects that currently we are working as BIM consultant for the biggest oil and gas project in the world that's being now in the design phase. So this is our BIM-based project controls roadmap, where we integrate the BIM processes with the planning and scheduling workflows, where we use BIM for scope management, quantity surveying and scope management, and this includes payment certificates and cost management. Also for cost control, to control the cash flows and the cost loading from one side, and in the other side, we use BIM for controlling material delivery, material management, and warehouse management, and also for controlling variations, finding clashes, creating RFIs, shop drawings, and reporting. Very important topic of BIM implementation was using BIM for procurement and material management. Sorry. In addition to controlling the quality of the construction process and how we can integrate BIM or the 3D model of the oil and gas field with QC forms, checklists, snagging, and then reporting in 3D environment. Finally, how to control the progress of the construction and apply advanced technologies or techniques of lean construction for controlling the process of the oil and gas on site, such as advanced work packaging, work phase planning, creating job cards, subcontractors, coordination, and control. This is an example of one of the projects where we control how to deliver isometrics to the site and how we control to see what is delivered, what is not delivered on site. This is something we used to implement in civil projects to control the material delivery to site and assign it to work breakdown structure and assign it to objects, and we implement the same in this oil and gas project. Of course, very important to for construction process to control the procurement and to track the procurement steps, and this is a color-coded extraction from a model. It's not only an oil and gas model. Now this is a BIM model where you can see the blue color means that the material arrived on site. The yellow color means it's manufactured. This color, gray color, means the client approved the material, and so on. So you can use this kind of color coding to investigate and test which item of your project was delivered or was delayed, has been approved or not. This is our workflow for controlling material delivery on site. All these steps of stock, store control, and material management, material issuance, purchase orders, creation, quotation, generation, and approval of material requisitions are generated and connected to a BIM model that is divided where the work breakdown structure and attached to the organization breakdown structure and the systems breakdown structure of the oil and gas project or of the plant. Here, this is a very nice example of how to track the quality of the components in the construction field. So, for example, the red here means that these are under testing by the client. The red is that were not tested, and the blue is in the progress of being tested by the client quality control team. This is another good example of utilizing this BIM methodology for tracking the status of each and every component of the oil and gas, such as what has been engineered, what has been quality control certified, what has been approved, what has been inspected, what has been issued to site, what has been installed, and what has been welded, and what has been certified by the client as approved by the quality control team of the client representative. And this is another example for those who are working in the oil and gas field, where you create test packs and you track test pack status in the field. So, for example, if the test pack was prepared, if the limit of the test pack was approved by the contractor, if this test pack is under construction by the contractor or subcontractor, if there is a punch list generated and there is some quality control issues, all these can be generated and traced from oil and gas models that are structured, framed, and being applied, or BIM workflows are applied to that model. This is also another example of how to utilize the same concept for the delivery of the steel and to track the material of the structural steel. And as you know, structural steel is one of the most significant items in the construction of oil and gases and of plants. This is an example of electrical and instrumentation, trenches, cables, drums, tracking, and it shows what has been pulled, what has been tested, and what has been installed on site. Also, definitely we have utilized 4D animation and integration, the BIM model with the construction schedule to visualize the plan and check the constructability of the schedule and make sure that the client has a good view of the planning, the productivity, and that his expectations are being managed and taken care of by the construction team. Also, this is another example of how this is a very important concept in the field of construction. When you are working on the structural steel, you need to figure out how to control loose items, because there's a lot of small items and loose items in the steel structure, especially in the connections, and you need to make sure that you are controlling the installation and material delivery to the site. This is also another example of how to utilize BIM models for controlling packages and contents, material components of each and every package, and ensuring the full and complete delivery of the assembly to the construction team, and without losing or without missing any component of the assembly. This is a visual progress that shows the progress of construction in the field, and each color code shows how much percentage of progress has been achieved. For example, green means it's 100% complete. Yellow, it is between 60 and 79% construction completion on site. This is another example of a 3D progress report. And at the end, I would like just to highlight the integration between the BIM model and the geographic information system, and how can you integrate the pipelines and also the plant 3D model, the building information model, and extract information that is necessary for geographic information system of the plant. Those are the different attributes that were extracted from the BIM model to the GIS shapefiles or the GU database. And as you know, we have been working on automating the integration between BIM and GIS, and we have managed to do this integration to a great extent, and there is a huge efficiency in the process of translating information and geometrical components from the plant models or the BIM models and GIS, and vice versa. Of course, we create dashboards for the client and the management of the project where they can witness the different reports about the construction site, about the different phases of the construction, from design phase, construction phase, and operation phase. Of course, for the structural components and also for the MAB components. And also you can trace, for example, this report shows the RFI status, shop drawing status, and different design and construction reports that are important for the top management to understand the status of the construction site. And if any action is needed, they can see the reports and make informed decisions. Different dashboards that shows important information about this report is very important because it captures the different assets in the construction site, and also it shows for the operation phase the performance of each and every asset. Here there is an integration also between each and every asset and the different sensors about this asset, and there is a layer of IoT or Internet of Things sensors where you can collect the different performance indicators of each and every asset, such as temperature, energy consumption, heat, carbon emission. You can collect all this information from the different sensors in one platform, one IoT platform that we own, and we collect all the information in that IoT platform, and we show the different performance indicators for each and every asset or for each and every system. Those are some examples of the dashboard where the assets of any plant or any construction is connected to a dashboard or to connect it to a neutral IoT platform where all the different sensors are connected, and a lot of reports are generated showing the performance of the facility, the performance of each and every system, and the performance of assets. You can detect and calculate the cost of maintaining each and every system and assets, because also we have done a lot of integration between facility management solutions and our portfolio of applications, including BIM and the center, and all the different systems and IoT platforms around the BIM platform. And then the BIM platform reads all the information from the different assets, from the facility management application, from the operation and maintenance workflows, and creates a visual dashboard where the client can get and retrieve tremendous amount of important reports, executive reports, that helps him to take the correct decisions about the performance and enhancing the performance of assets and facilities. This is the, I don't want to take more from your time. This is the end of the last slide of today's presentation. I hope I could give you a good exposure of what or how can you leverage BIM in the field of plants and oil and gas. Thank you so much for listening, and Gnasi, the floor is yours.
Thank you so much, Issam. I think it has been something amazing to see this kind of application of BIM in these kind of projects. And well, I don't want to abuse of your generosity, Issam. So I want to make only one question. That is, we have seen, for example, that you are using Tekla for the metallic structures of one plant. How many different software are you using usually in this kind of projects?
Thank you so much, Ignacy. Yes, in this kind of projects, we use a portfolio of solutions. For example, we are using Tekla for steel detailing and concrete detailing. We are using Revit or a Bentley Open Building Designer for other infrastructure works like roads, highways, subsurface utilities, and buildings, other buildings. And we are using BDMS or BDS for the plant itself. And sometimes we are using Open Building Designer or open plans for creating the plant itself. So those are the, of course, we are using, for example, what you see in front of you this is the recent project that it was awarded to AIDIGITS, where we are the BIM consultant for an oil and gas project. This is a running project in the design phase now. It's the biggest project in the world. I cannot say details much because it's in the, but what I'm showing you is a real project where a huge plant is being given to us as a BIM consultant to apply the same BIM workflows to the different components, to the equipment, to the vendor equipment, to the structure steel, to the electrical installation. And we are adopting, for the sake of creating a platform where the construction team can utilize advanced work packaging techniques and create daily tasks for the construction site. Using, so each and every foreman will understand what he has to do today, tomorrow, next week, and if he has enough information to do, and material, and labor, and equipment, to do properly the work without interruption. This is a real, of course, I cannot zoom out, it's huge. If you see the whole project, it is tremendous.
This is the challenge, no, for each one of these projects.
Exactly. The challenge is the size and complexity of the design models. There is around 30 different designers working on that. Each one has his own method of work, and interoperability is a big challenge here. Yeah. And part of our work is to ensure that all these different designers and contractors work on the same level of information and interoperability is achieved.
Yeah. And let me ask you the last question, and I stop here. We have been analyzing with Leonardo Mata in the session before yours about how the BEP, the BIM execution plan, has to think about confidentiality of one project. How you are dealing this in a contract, in a BEP, in a BIM execution plan for this kind of projects?
This is a great question, Ignace. And as you know, there is a huge debate about contractual obligation and IB rights for the design. There is a huge debate. So far, there is, the industry could not find a best solution for that. But for us, we found, I cannot say we found the best solution, but we found a solution. The solution that we found is that, of course, during your work with any of the vendors, any of the subcontractors, anybody, before they sign any subcontract agreement, you need to include all the clauses that ensures at least minimum what he needs to deliver and how he can protect himself and how others should respect what he is doing. At least this should be happening before you sign the contract with any subcontractor. So the BIM execution plan should be included in the contract. All the components of what he needs to do should be clear as much as possible from day one. The challenge is that you are asking them to follow these, but after the contract is signed, and this is going to be too late. What we are doing, we postpone a bit the contract signature. We sit with each and every vendor, each one. We had 120 in one project. We sit with 120 and develop what we call it an EDI, electronic document interchange, that contains a BEB, contains all the contractual, what he has to deliver for his discipline, and how we can ensure that he owns this information and how he can protect others' information.